Hello guys, we are going today to define new concept which is the concavity and the second derivative test. Here, what is the meaning of concavity? The curve open to up or open to down, open to up or open to down. Here, let f be differentiable on an open interval. I. The graph of f is concave upward on I if the first derivative is increasing on the interval. If the first derivative is increasing on the interval, so the function will concave upward. And the function concave downward on this open interval if the first derivative, the first derivative is decreasing on this interval. Let's show you in the graph number 1, which at the left. Here, as you see the curve of the function, concave upward, in this case, the first derivative is increasing. And the graph will be above the tangent what? Line. If you draw a tangent lines to the graph at each point, the curve will be above it. If the curve concave downward, as you see here, we have a relationship between the first derivative and the concavity. Here, if the first derivative is decreasing, the curve concave downward, and the graph of the function under what? Or below the tangent line. That is the meaning of concavity. Function like this one, concave upward. Or like this one, concave what? Upward. But function like this one, concave what? Downward. Like this one, it means concave downward. Look here. Wait. Look here. I'd like to tell you the theorem about the test of concavity. Means how to identify, not from the graph, only from the rule of the function. If I give you the rule of the function, how to know the interval on which is the function concave upward or concave downward. Here, let f be a function whose second derivative exists, on an open interval. If the second derivative greater than 0, it means positive, for all x in this interval, then the graph of the function f is concave upward on this interval. If the second derivative less than 0, for all x in this interval, the graph concave upward. Concave what? Upward. I'll show you everything. Look here. Now, as you know, the concavity and the relationship between the first derivative and the second derivative, between them and the concavity. Here, state the sign of the first derivative and the second derivative on the open interval 0 and 2. Here means I know the sign of the first derivative is the slope of the tangent. Here we draw a slope of the tangent at this point. Here, in this case, the slope of the tangent, at each point to the graph of this function on this open interval, positive or negative? It is positive, right? It is what? Positive. So, the derivative is what? Greater than 0. Why? Because the first derivative is the slope of the tangent. That's right? And as you see, the curve here is the what? Concave upward. So, the first derivative, the second derivative greater than, according to the theorem, according to the theorem 4.7, I think, if the curve of the function concave upward, in this case, the second derivative greater than 0. Try to solve with me number 2, okay? Here, to know the sign of the first derivative, draw the tangent what line? In this case, the tangent line, its slope is negative. Since the slope of the tangent negative, the first derivative is what? Negative, less than 0. And as you see here, the curve of the function is what? Concave downward. Concave what? Downward. In this case, so the second derivative is what? Less than 0, because I have a relationship between the concavity and the second derivative. If the second derivative negative, concave downward. If the second derivative positive, concave upward. Okay? Here, in this case, another one. Means if I draw the tangent, as you see, it's positive. So the first derivative positive. Since it concave downward, okay, the second derivative is what? Negative. Or by another way, less than 0, less than 0. Okay? Here in the last one, as you see, okay, a concave upward, it means the second derivative greater than 0. Since the tangent of the line, line for this curve of function, the slope of the tangent is what? Negative, so the derivative less than 0. I hope you understand. Okay. This worksheet I'll discuss with you, okay, in live session. Try to understand the explanation in this video and prepare all of your questions, what exactly you don't understand, okay? And I'll discuss with you in the live session, okay? Now, here, in exercise 5 to 18, determine the open interval in which the graph is concave upward or downward. This one, if you talk about the concavity, please focus with me. We will use the second derivative. We use what? Second derivative. If the second derivative greater than 0, okay, concave upward. Less than 0, concave downward. Okay? Let's solve now. Here, I have to follow the steps. The first one, find the derivative, which is what? 2x minus 1. Second step, that is for concavity. Second what? Step. Here, the second derivative, it will be what? Here means the second derivative, it will be 2. Means here, second derivative greater than what? 0. For all x in the domain. What is the domain here? All real number. So in this case, the function, what? Concave upward is concave upward for all x. This means on which interval or real number, which means negative infinity, and or real number from negative infinity to infinity. Okay? Since the second derivative is positive for all of it is constant, positive for all of the values of x. I hope you understand. Positive, okay. Concave upward is concave upward on all of real number, which is its domain. Okay, let's solve a number. I'll solve number 7. Leave number 6 as the homework. Number 9, we have a number 9. I'll solve number 7. Okay, I leave some question for you and the others for me. Okay, here it's so trivial. Find the same steps. Means I have to use the second. I have to use what? The second derivative. Okay. The first step, find the first derivative, g prime x, it will be what? 6x minus 3x what square. The second step, find the second derivative. Okay, please focus. It will be 6 minus 6x. Then find the zeros of the second derivative, because I have to discuss the sign of the what? The second derivative. It will be 6 minus 6x equals 0. The zeros of second derivative implies x equal what? 1. Okay? Then use the second derivative. Second what? This line for the second concavity, second derivative. Increasing, decreasing, first derivative. Find the critical number, draw the line. Okay? Here, right? Here, the second derivative at 1 equal 0, which divide the interval or the domain of the function into two intervals. Okay? The test value, what is your test value? I'll choose here what? 0, and here I'll choose what? 2. Replace in what? In the second derivative. Concavity, second derivative. I replace here, it will be 0, 6. Second derivative here what? Sorry, why? Okay. Equal greater than what? 0. Since it is greater than 0, concave what? Upward. Here, concave what? Upward. Okay, this one, 2, I replace in the second derivative. Here, okay, it will be what? Negative 12. Less than 0, concave what? Downward. In this case, the function g here, gx, is concave upward. Where? Which interval? This interval, which is what? Negative infinity and, okay, negative infinity 1. Gx is concave downward. Downward and what? On which interval? 1 and infinity. I hope you understand. Repeat again. Here, find the first derivative, second derivative, zeros of the second derivative. As we did with the first derivative, I will do with the second derivative. Here to find the concavity. Okay? Clear or not clear? This upward, this downward. I hope you understand. Okay? Would you like to solve number 9? Okay, I can solve number 9. I'll solve number 9. That is the last question in this session. What is the first step? What is the first step? Here, so clear. Find the derivative, f prime x. It will be negative 3x squared plus 12x minus 9. This is what the first derivative. I think it's okay. Then find the second derivative. That is to find the concavity. I have to follow the steps. Here find, it will be negative 6x plus 12. Okay? Then third step, find the zeros of what? Of the second derivative. Second derivative. Negative 6x plus 12 equals 0 implies x equal what? 2. Then the fourth step, draw the line of what? For second derivative. For what? Second derivative. What is the value at which the second derivative equals 0? 2. And as you know, negative infinity, and here what? Infinity. That is the fourth step. Fifth step, test value. Here I choose which test value here. I'll choose number 1, which is less, and the number 3, which is big. Replace in which value? In the second derivative. In what? Second derivative. Okay. If I replace by 1, it will be 6. Second derivative equal what? 6. If replace here, negative 6 plus 12, it will be 6. Greater than 0. Concave what? Upward. Concave what? Upward. Okay, 3, it will be negative. Okay, it will be 3 negative 18, but it will be negative 6. Less than 0. Less than 0. Less. So in this case, F is concave upward. Where? On the interval on which the second derivative greater than 0, which is what? Negative infinity 2. F is concave downward. On which interval? To infinity. Okay, follow the steps as we did with the first derivative. To find the interval in which the function is increasing or decreasing, I will do here, but with the second derivative. Okay, I hope you understand the lesson. It's so easy. Prepare all of your questions that you would like to ask in the live session. Thank you. Bye bye.